This next chapter is going to take a look at fractions and how we work with fractions. And at the foundation of fractions, this idea of being prime or composite. And to understand that, we have a little bit of vocabulary we want to go over to get started with this chapter. The first vocabulary word we need to know is the word divisible. A number is divisible by another. That means that a number that can be divided by another number. In other words, I could take the number 16 and I can say it is divisible by, well, I can divide 16 by 8, so we say 16 is divisible by 8. In fact, that's not the only thing it's divisible by. It's also divisible by 1, 2, 4, 16, a whole list of numbers that it's divisible by. Those things that it's divisible by, those things we call factors. Factors are the numbers that can divide into another. So if 16 is divisible by 8, we can then say 8 is a factor of 16. And again, those other numbers are also factors of 16. Also, 1, 2, 4, and 16 are factors of 16. Now, with 16 has lots of factors. 1, 2, 4, 8, 16. We're particularly interested in when a number only has 2 factors. When a number only has 2 factors, we say it is a prime number, a number with exactly 2 factors. And those 2 factors are always going to be the number 1, because everything's divisible by 1, and itself. And it has to be 2 unique factors. So we'd say the number 1 is not a prime number because it only has 1 factor, 1. An example of a prime number would be like the number 2. It's only divisible by 1 and 2. Or 3. It's only divisible by 1 and 3. And then 5 is also prime. 7 is prime. Notice the number 9 is not prime because it has a factor of 3. 11 is prime. 13 is prime. And in fact, there are an infinite number of prime numbers. 97 is the largest 2-digit prime number, but there are a whole bunch of 3-digit prime numbers, 4-digit prime numbers. They go on forever, really. Lots of prime numbers. And these prime numbers are going to be the foundation of how we work with our fractions. But while we're talking about prime, let's also define the opposite of a prime, which is a composite number. A composite number is a number with more than 2 factors. And we've already seen the number 16 has a lot of factors. It's got a factor of 1, 2, 4, 8, 16. We can divide 16 by all of those numbers. 16 is composite. 9 is also composite. It's divisible by 1, 3, and 9. It has more than 2 factors. It is a composite number. Now, when working with fractions, we often want to find prime numbers that we can divide into larger numbers. And to help us do that, we have these things that are called a divisibility test. There's lots of divisibility tests, but we might be interested in the divisibility test for 2. How do I know if a number can be divided by 2? Well, the way we know is we say it is even, or it ends with either 2, 4, 6, 8, or a 0. So, for example, the number 1084, because it ends in a 4, we say, yes, it can be divided by 2, because that last digit is a 4. If I took a look at the number 2793, we're going to say, no, it is not divisible by 2. 2 is not a factor. I can't divide by 2 because the last digit is not even. So a really quick divisibility test to see if a number is divisible by 2, yes or no. The next prime number is 3. And 3 has an interesting divisibility test. We're going to add the digits and divide by 3. If we can do that, it means the number is divisible by 3. So if I've got the number 13,791, and I want to know if I can divide it by 3, what we can do is we can add up the digits 1 plus 3 plus 7 plus 9 plus 1, and that equals 21. And I can do 21 divide by 3 to get 7. Because I can divide that by 3 after adding the digits, we can say, yes, the whole number is divisible by 3. Compare that to the number 7,981. If I add those digits together, 7 plus 9 plus 8 plus 1, we end up getting 25. I can't do 25 divided by 3 without getting a remainder. So that means the larger number, 7,981, does not have a factor of 3. It is not divisible by 3. The next prime number is 5. The way we know if a number is divisible by 5 is we look at the last digit. Is the last digit 0 or 5? So for example, if I've got the number 173,985, because the last digit is a 5, I know, yes, the entire number is divisible by 5. Compare that with 14,296. Because the last digit is not a 0 or a 5, we're going to say, no, that number is not divisible by 5. Every prime number actually has a divisibility test that goes with it. But as they get larger than 5, some of the divisibility tests get a little more complicated, and it's just easier to divide by the number to test it. But for the numbers 2, 3, and 5, we can do a quick divisibility test to check, can we divide by that number, and then use that to help us simplify some problems with fractions that we'll see in some later videos.